Okay, 22 is going to be slope and rate of change. '22 is slope and rate of change, and 23 is going to be Mr. Slope. All right, so let's turn to these pages. So 22 is slope and rate of change. And we'll do Mr. Slope after we're done with slope and rate of change notes. So 22 is slope and rate of change. All right, so the key part about slope, is that slope is always a fraction. And if it's not a fraction, we need to make it a fraction. So there are multiple ways of thinking about slope. Slope is the ratio, and ratio is a fancy word for fraction. It's a ratio that compares the amount of change in the dependent and independent variables. So slope is the ratio, it's a fraction, that compares the amount of change in the dependent and independent variables. And we've been doing slope for a few weeks now. You just haven't called it slope. We've called it the rate of change. We've used this formula. The change in y over the change in x. The change in y is the dependent, and the change in x is the independent. Slope. It's a fraction. An easier way of writing this is you may see it like this. And this triangle is called a delta. It's a Greek letter. It's the Greek letter D, delta. And in science, especially physics classes, they're going to abbreviate the word change by using this symbol. This symbol, delta, means change. So let's copy a table really quick, just as a refresher, because we've done this quite a bit already. If the year is our x value, right, we have no control over time, so that's independent. And the cost is my dependent. the cost is going to change, whereas the year, we really can't do anything about that. So if we have 1988, what should we say, was 25 cents. And in 1990, it was 25 cents. In 1991, it went to 29 cents. 2004, 37 cents. And 2008, 42 cents. Why not, right? We can find the slope, or the ratio that compares the amount of change in the dependent and independent variables. The change in y over the change in x. Delta y over delta x. In any table, the first value is the x value, the second value is the y value. So what's the change from 25 cents to 25 cents? 0. What's the change in the x value from 1988 to 1990? 2. So my slope would be 0 over 2. What? Yep. What's the change from 25 to 29? 4. And what's the change from 1990 to 1991? 1. So my slope, my change in y over change in x, is 4 over 1. What's my change from 29 cents to 37 cents? 8. And what's my change from 1991 to 2004? 13. So what's my slope? 8 over 13. From 37 to 42, 5. And from 2004 to 2008, 4. These are my slopes. Is this linear? No, it's not linear. Why is it non-linear? Yeah, the rate of change is not even every time. If it was going to be linear, all of these rate of changes would be equivalent, and they're not. Now, some people are going to tell you that 0 over 2 can be simplified to 0. And that's true, but you also have to realize that slope is always a fraction, so you need to be able to make 0 into a fraction. Can you do that? Yeah, I mean 0 over anything. So as long as you know, so could 4 over 1 be simplified? It could be simplified to 4. But you have to know that if they ask you for slope as a fraction, you have to be able to make it into a fraction. Slope can never be a mixed number. 5 over 4 stays 5 over 4. Do not simplify it. It's, if this could be simplified, it'd be best to simplify it into its simplest fraction, just because it's less work in the long run. But never simplify it to a mixed number. You also need to know that slope is sometimes easier than this, than subtracting, change in y over change in x. Sometimes slope is from a graph. So slope from a graph. Again, slope from a graph is a fraction. It has to be a fraction. Because by definition, slope is a fraction. Slope from a graph measures the steepness of a line. It tells you how inclined it is, how steep it is. And you use the formula rise over run. Rise is up or down, and run is left and right. You guys, what kind of numbers go up, positive or negative? Positive. So if you're counting up, it's a positive number. What if you're counting down? It'd be a negative number. What if you were counting to the left? What kind of number would that be? Negative. And what if you counted to the right? What kind would it be? Positive. So up is positive, down is negative, to the right is positive, and to the left is negative. Here are the steps to follow. Start at the bottom dot. And this will make sense once you see a picture. Start at the bottom dot and count up. Number 2. Count over to the top dot. And 3 is just you have now rise over run. So we're going to draw a few quick pictures. I'm going to make them pretty easy. Again, they don't have to be beautiful, but they do need to kind of look good because we're going to be counting on them. So the first one I'm going to draw 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Don't make it too complicated. And let's put a dot here and here. All right, what's step number 1? Start at the bottom dot. Found it. Start at the bottom dot and what? Count up. How high am I going to count? Tell me. 1, 2, 3. I went up 3. What kind of number is that? Positive. So up 3. Rise 3. I went up 3. Now I'm going to count over to the top dot. Why did I stop right here? Why didn't I keep counting? Because I'm even with the top dot. So now I need to turn the corner. All right, how many do I count over? 1, 2. And I went to the right. I moved to the right side. I moved to the right, so it's a positive 2. 3 over 2. Do not simplify to a mixed number. That's your answer. Bless you. Let's do this. Bless you. If there's more than 2 dots, you just pick 2. Doesn't matter which 2 you pick. All right, so that's a good question, right? If there was another dot up here, you just pick 2 dots to count. Any 2 dots on the graph. Doesn't matter which ones, because you'll always get the same answer if it's linear. If it's not linear, you can't do slope because slope only works for linear graphs. All right, so we start at the bottom dot, and how high do we count? 1, 2. And I stopped here because I'm even with the top dot. And now I'm going to count over 1, 2. So do I put 2? No, what do I put? I put -2. Why do we put -2? Because you went to the left when you counted. You went backwards. Here's my hint to you guys. If it makes the letter N, your slope is negative. If that diagonal is the diagonal in the letter N, your slope needs to be negative. Can you simplify 2 over -2? Two over -2 simplifies to what? -1. You do simplify, you just never simplify to a mixed number. Because can you make -1 into a fraction? How? Putting it over 1, -1 over 1, and then we're good. But do not ever make it, don't make 3 over 2, don't make that into 1 and 1/2. All right, last 2 pictures. All right, start at the bottom dot. Which one's the bottom dot? Where is it? They're both the same, aren't they? So does it matter? All right, I'm going to pick this one. How many spaces do I go up? What number means none? 0. And how many spaces do I go over? 1, 2. Can you simplify 0 over 2? To what? 0. Ladies and gentlemen, a horizontal line has a slope of 0. Because remember, slope measures steepness. How steep is this horizontal line? It's not steep at all, right? It has 0 steepness. You simplify, but you never simplify to a mixed number. Last picture. Start at the bottom dot. All right, how many spaces do I go up? 1, 2. I go up 2. How many spaces do I go over? None. Ladies and gentlemen, what do you know about 2 over 0? What do you know about 2 over 0? So vertical lines are undefined. How I think of it is, can you ride your bike up this hill? Yeah, it's going to be a lot of work, but it's positive. You can go up this hill. Can you ride your bike down this hill? Yes, it's dangerous, it's a negative, but you can. Can you ride your bike across this? Yes, it's zero fun because there's zero slope. And can you ride your bike against this hill? No, it's impossible, it's undefined. So positive goes up, negative goes down, zero is flat, and undefined is vertical. If you put down Mr. Slope, he's also another way of looking at it. Lines that go up are positive. Negative lines go down. Vertical lines are undefined. And horizontal lines are zero.